Hello and welcome. My name is Shannon Kemp and I'm the Executive Editor for Dataversity. We would like to thank you for joining today's Dataversity webinar, Data Systems Integration and Business Value Part 3, Warehousing. This year's September edition in a monthly series called Data Ed Online with Dr. Peter Aiken, brought to you in partnership with Data Blueprint. Now let me give the floor to Megan Jacobs, the webinar coordinator from Data Blueprint, to introduce our speaker and today's webinar. Megan.
Thanks, Shannon. Hello, everyone, and welcome. My name is Megan Jacobs, and I'm the webinar coordinator here at Data Blueprint. We are pleased that you found the time to join us for today's webinar on Data Systems Integration and Business Value Part 3, Warehousing. As always, a big thank you goes out to Shannon and Dataversity for hosting us. We'll get started in just a few moments after I let you know about some housekeeping items and introduce your presenter. We have 1 hour for the presentation, followed by 30 minutes of Q&A. We'll try to answer as many questions as time allows, but feel free to submit questions as they come up throughout the session. To answer the top 2 most commonly asked questions, yes, you will receive an email with links to download today's materials and any other information you request during the session within the next 2 business days. You can find us on Twitter, Facebook, and LinkedIn. We've set up the hashtag DataEd on Twitter, so if you're logged on, feel free to use it in your tweets and submit your questions and comments that way. We'll keep an eye on the Twitter feed, and we'll include answers to those questions in our post-session email. Now, let me introduce you to our presenter. Peter Aiken is an internationally recognized data management thought leader. Many of you already know him or have seen him at conferences worldwide. He has more than 30 years of experience and has received many awards for his outstanding contributions to the profession. Peter is also the founding director of Data Blueprint. He has written dozens of articles and 8 books. The most recent is The Case for the Chief Data Officer. The best way to get copies is through Dataversity's bookstore. Peter is experienced with more than 500 data management practices in 20 countries and consistently named as a top data management expert. Some of the most important and largest organizations in the world have sought out his and Data Blueprint's expertise. Peter has spent multi-year immersions with groups as diverse as the U.S. Department of Defense, Deutsche Bank, Nokia, Wells Fargo, the Commonwealth of Virginia, and Walmart. He often appears at conferences and is constantly traveling. Peter, where are you headed this week?
So this week I've got a couple of stops to make. I'll be in Washington, D.C. and New York City, and looking forward to both groups that I'll be meeting with up there. We'll be having a lot of fun. Thanks, Shannon. Thanks, Megan. I think Shannon almost called you Megan JPEG. Could do that for an interesting, right, exactly. We'll work on that. Nicknames are always fun. So hi, everybody. Today is the third in our 3-part series talking about data systems integration and, more importantly, business value. And the third part here, we're calling it warehousing et al. And the reason for that is because there are warehousing, which is what people have tended to gravitate towards. But what we're really trying to do is say, how can we use warehousing and related technologies to solve business problems? As always, our format here, what we start out with in particular is an overview of data management. So we all start off literally on the same sheet of paper. Then I'll move into a motivation section where we'll talk about integration technologies, and in particular look at sort of reporting BI and analytics, which is what a lot of people are interested in these days. We'll talk about what warehousing technologies are specifically. We'll look at the architectural focus on those warehousing, and we'll look at some starting places. The real key for a lot of this is that we've done so much of this over the years, we do not have to start out with a blank sheet of paper. And anybody that does tell you to start out with a blank sheet of paper, you need to go find yourself some other folks to work with on here. We'll finish up, of course, with some guiding principles, and since we're summing up the entire series here, we'll come back to look at some of the things that happened in the first 2 sessions as well. And as usual, go to our Q&A session at that point. So let's get started and take a look here again from our perspective. Data management consists of 5 integrated data management practice areas. This is the chart we always show management and then promise them they don't have to actually memorize it. But really what we're looking at are 5 integrated practice areas. The first one is called data program coordination. And the idea here is that we need to manage the data coherently. If we're not singing off the same sheet of paper, just like we're doing in this webinar, then you have good people putting lots of effort into things, but they are not going to be anywhere near a sufficient or critical mass in order to make a positive impact on your organization. The second one is that your organization is sharing data all around, whether it's from program to program, from part of your organization to another part, say between the marketing department and the manufacturing department, or whether it is between your organization and your organizational data sharing partners. You need to do this in an efficient and effective manner. If you don't, again, you're wasting money and resources, and that's silly in today's environment. Third component is data stewardship. The idea is that some people must be put in charge of it. The minute it says, Peter, your next raise depends on improving the quality of the manufacturing data by a certain percentage, you better believe I'm going to focus my time and attention on it. But if we leave it the way it has been, which is the data is everybody's responsibility, it's really everybody else's responsibility, and nothing actually ends up happening as a result. Fourth area is data development. This is the idea that making sure we engineered the appropriate data delivery systems. In the past, this has meant building relational database management systems, whether they are warehouses or other. In many instances, however, we can now start to turn to additional tools, virtualization, linked data. We'll explore some of these a little bit later in the webinar in order to do this. And for the most part, colleges and universities teach you only one way of doing this, not that there are a number of design alternatives that should be considered in this process. And our fifth area then is data support operations, which the analogy here is of course very much like a car. You simply can't drive it. You need to put fuel in it. You need to change the oil. You need to tune these warehouses so that they continue to deliver value, assuming you get to the point of delivering value in the first place. So let's part about all this too. We're going to look specifically at Maslow's hierarchy of needs, which everybody kind of understands as if your food, clothing, and shelter components are not met, then the rest of your self-actualization activities become very difficult. And we put warehousing in the top of this data management triangle because the 5 data management practice areas I've just described to you provide a necessary but insufficient foundation for doing all of the fun things that everybody wants to do, what I call the data self-actualization components. You can see I've listed several of them here, which are the topics of several of our webinars that we do as we work our way around the calendar year on this. Warehousing falls into that category. If you do warehousing without the basic data management practices, you can do it. You can be successful, but it will take you more time, cost more money, deliver less business value, and provide a greater source of risk to the organization than if you didn't put these practices in place. So there's our practices in here. As always, we're hoping you all are using this educational material to prepare for the DAMA Data Management Body of Knowledge CMD, Certified Data Management Professional Certification. About 1,200 of you worldwide have gained this designation. Some of you have done this with the benefit of these courses, and we're very pleased to be able to help you out in doing this. It's a series of 3 exams presented by DAMA International and the ICCP in conjunction. It focuses in on specialized knowledge in this area, which is something then that you can take forward, and we are seeing more and more jobs coming out where they are asking specifically whether the CDMP can be a part of the qualifications in that area. If you have additional questions about that, we put the links to dama.org and the ICCP on the website there for you as well. Now again, our content here is that most organizations are trying to solve an integration problem. You need integration to solve the problem of disparate data when you have a bunch of other things going on in the organization and you need to take something from pile A and pile B and put them together. The idea here is, of course, most organizations try to do this, but for one reason or another they fail miserably in this, and our research and study here shows that the most primary cause of failure is the adoption of a single pillar. We want you to look at this as people, process, and technologies, and the technologies tend to work pretty well if you know how to use them correctly. People tend to look at these technology pillars as silver bullets. I almost said single bullet theory there. I don't know, Shannon, you remember that was an old punk band from the old days in here. And these webinars that we've done the last couple of months here on metadata and cloud have been designed to provide a foundation, and the third one here, of course, is this one on warehousing. Again, the takeaways for part one were that metadata as a definition, you need to know what that definition is because Gartner has provided us with an excellent one. Metadata unlocks the value of data and therefore requires management attention. Good for Gartner for putting that one in place. Metadata is therefore the language of data governance, and it describes the essence of these integration challenges. Metadata practices consist of sources and uses of data and linking them together with specialized team skills that involve metadata engineering, metadata storage, metadata delivery, and metadata governance. That was our first one. Our second one that we did then was the cloud here, and the takeaway from that is that governance, architecture, and quality are necessary but insufficient prerequisites to cloud. The cloud options influence the architectures of your solutions, and these technical architectures are extremely important because it's very difficult to architect after implementation. So in order to put data in the cloud, we have characteristics that we'd like it to be less, of higher quality, and more shareable. Because after all, when you put your data in the cloud, you start to pay for it every time you put it in and take it out, and becomes a lot more expensive. So there's a high incentive for the vendors to not tell you these things, but for you to in fact know that if you don't do this re-engineering of your data in the cloud, it will result in business value for the vendors. Now again, our summary of what we're looking at today here is from the DMBOK as well, the Data Management Body of Knowledge, and you can see here it's in the form of an IPO diagram. We have inputs down the left-hand side, activities that are around it, and deliverables that come out on the right-hand side. Look at a couple of goals, which are to provide business analysis and decision-making by knowledge workers and to maintain environments that support these things all the way around. You see the participants on the bottom. We'll come back to those in just a bit. So let's dive in here now with some motivation and take a look at what's actually happening in these areas. And a typical example of this involves portfolio analysis. If I've decided that I'm going to be in the banking business, just to pick one for example, then bank accounts have certain values. Some of them can be more valuable than others, and these might depend on different things. The typical process for doing this is that we cube them. Now we call it a cube, but the cube is really an n-dimensional space. We might want to, and we'll just show three examples here, cube it by social status, by geographic location, and by the net value of the clients that are involved. We could then figure out what types of loans we're going to sell as a product. And we look at the return on the loan and balance that against the risk of default. The question, of course, is how do we evaluate the portfolio at all? The least risky loan may be to sell loans only to those that are very wealthy because they have a very low default number, but there are not very many very wealthy. Some people call it the 1%. If you go the opposite extreme and say we're only going to give loans to poor customers, we can charge a higher interest rate to the poor customers because there is a greater risk there, and there are many more poor customers, so it's relatively easy to sell to them. But on the other hand, again, you do have a challenge there of a higher risk of default. So your solution may be to put some data in a place where you can start to analyze it. And this data may come from disparate sources. The social status information, for example, may come from your marketing department. The geographic location, however, may come from the local counties that you're working in. And it's very unlikely that those two data easily work together because if they weren't designed to work together, it's very unlikely they will. In fact, you can look at that with almost any of the systems that are in your environment. If the data wasn't specifically designed to work together, it's unlikely that it will actually work together very, very well. Now, in order to figure out then when to lend and what types of interest rates to charge, I may need to go in and do some analysis in this environment and to take the disparate data and put it into one place so I can, again, cube it and look at it and say, okay, where are the retail parks, where are the shopping centers, where are the places I should put these things in? Again, lots of different questions that as a banking person, you may actually look around and say, where did these things go? Here's another example, and many of you have heard of this example from Target. Target's a wonderful company. They do a lot of really good things where they keep access to an awful lot of data about their guests. And they centralize it all on something called a guest ID. This is not a target alone model. They happen to be very good at it, but there are other organizations that do very similar kinds of things in order to do this. So when you're recognized as a guest, Target knows a lot of things about you. And that information helps them put together goods and services that serve you better. Now, there's a terrific story around this about Target predicting pregnancies that Stephen Colbert made fun of one afternoon on his show. It's a terrific piece. If you have trouble finding that, let us know, and we can point you to the date on that one. But also some of the Target analysts have done some really interesting talks around the web, and finding them, again, are worth looking into just to see what's happening there. Here's another final example, a local company here called CarMax. And CarMax has some really interesting things. When they look at job postings that are out there, they look at targeting individuals who are interested in solving original, wide-ranging, and open-ended business problems, who are not only discovering new insights, but also implementing those insights, making a mark on a growing company, and developing skills for a rewarding business career. They actually talk about owning an area of the business and being expected to improve it. So here's clearly 3 examples of different companies that have taken this sort of warehousing approach to things and trying to make sense out of it. And what CarMax can do when they accumulate data from more than 500 stores in a repository of some sort of warehouse, they can analyze this and look at things that are happening, whereas their competition in the local used car market doesn't have access to this kind of data, and therefore doesn't know that the Volkswagen Beetles that they're buying in the Midwest will actually sell for a premium if you can get them to the East Coast, or something like that. I'm not certainly giving any strategy away on CarMax in there. Now let's talk about some definitions. Again, this sort of lumpy area that we call DW, data warehousing, analytics, BI, and I'll call them all meta integration technologies here. It's really beyond the bolts and nuts of data management. As I said earlier, it's in that self-actualizing aspect of the triangle in there. What this really means is that we're looking to analyze information that hasn't been previously integrated. So we're going beyond a transaction or a group of transactions in a integrated system, something like an ERP, an SAP, a PeopleSoft, an Oracle applications thing in here. The term business intelligence actually dates back to the year before I was born in 1958. And the idea here is that really we're just trying to support better decision making using data. So it's had this definition all along, but now we've taken on this additional aspect of not just making better business for it, but it's the collection of these technologies, these applications that allow us to present and analyze and integrate the business technology. Now, I should point out, most of these technologies do not do the integration. The integration is done by a task called ETL, extract, transform, and load, and then we load the data warehouse with integrated information. So the warehouse, well, some people think it does the integration. That's not necessarily the case, although, again, you're maybe conversing with business people, and that may be a very, very different discussion that you have here. It's also described as decision support, particularly in the healthcare environment. You'll see that term used an awful lot. So then let's move on to the term data warehousing, and what this is the idea that we're going to set up a set of procedures for routinely and programmatically extracting, cleansing, transforming, that's the ETL, and loading the data into these places that give you this single conceptual database that take the disparate data, pull it all together, and analyze it into a single conceptual database. The idea here is, of course, that it's only one place that you have to go to get all your data needs done, because if you have it in 2 separate places, again, the likelihood that it will be integratable is very, very slim unless it was explicitly designed to be there. So let's go a little further and look at some of these as well. People try to look at this and say that it's a study of data to uncover historical patterns and improve future performance. Terrific, no problem at all. Some people say it's just the use of mathematics in business. And from that perspective, certainly there's a component that says that statistical mining and things is going to be in there. In fact, this analytics closely resembles statistical analysis data mining in the sense that you're using this extensive computational capability and these extensive piles of data to do vastly larger amounts of computing than you were able to do before. Gives us the ability, again, to understand it. Does require that we model this data in order to understand it. Some of the fields then in this area are these enterprise decision management, marketing analytics, predictive science, strategy science, credit risk analysis, fraud analytics. We get lots and lots of names for them. There's bunches of new job categories that we can look at in these areas. Let me give you just an example of how this works. This is something called set analysis. It's from MicroStrategy, a very fine BI tool company that we've used on and off over the years. And the first challenge here is, well, I'd like to get a list of customers with an income of less than $100,000 or who are younger than 30 years. So I may take a very large set of data and chop it down to 30,000 of those customers. When I look at that then, I say, that's great. Now I'd like to take that set and apply something called an online analytical processing filter. That's it up on the top under the red arrow there. And I'd like to find out, again, customers with income of less than 100,000 or who are younger than 30 years. That's the first chop that I made at the data, and who live in the state of New York. And now I've taken that original 30,000 list of customers and chopped it down to 6,000 customers. Well, I may not still be at the solution for my problem. I may instead do a relational online analytics filter. Okay, and don't worry about the specifics of the technology because there's lots of different options that are there. That's just the one that they're using in this example. And say, let's add again less than 100,000 or greater than 30 years and living in New York, and let's add an additional constraint. I want to find out if they've purchased something in the last 30 days. Excuse me, I said 30 days, 7 days. That gives us now a results set of only 800 customers. And finally, at this last part, I can drill across in that roll-up set, okay, again, the set of 800 customers, and say who were the suppliers who served the list of customers with income less than $100,000 or younger than 30 years and live in New York and purchased within the last 30 days. And there are 40 of those suppliers. And I can go from there to the next step, which is that the detectives in Law and Order would then go out on the street and talk to each of those 40 suppliers and find out which of them sold the particular whatever it was they were trying to sell it to in there. So again, it's sort of a detective-y kind of thing, but at the same time, it does give a very good analysis of what we're trying to do, and the point of putting it together into something like a warehousing technology is that you have it all in one place. Now this leads us to our first question for you all, because we're interested, and as you know at Data Blueprint here we do a fair amount of research in this area. So we have a question for you that we'd like you to tell us. Do you have data marts or warehousing integrations? And answer A for us if it was last year, B if you this year, okay, did you start them, or is it C next year that you're going to do? We're trying to get a trends analysis on this. So we're going to give you a quick minute on this to reply to us, and we'll report those results back to you. Hopefully it'll be interesting to you all as well. What we're tending to see is that this technology is on the increase. So we'll get those results and analyze them. So again, just a quick another minute here. Megan, let's talk and see when we've got everybody ready on this.
All right, we've got about 10 seconds left till it closes, and we'll see what the results are.
And I always like everybody to know that we know to leave it open for the optimal amount that produces the right amount of results on this polling question, because Shannon is an expert in this area, and she tells us to leave the questions open for, I believe it's 50 seconds in order to produce the optimal.
Yep.
Did I hear you giggle there, Shannon? Got it, Megan?
Yep, let's see. We should be able to show those. All right, and it looks like A had 26%. B had 11%, C was 8%, and D was 17%.
Interesting. Okay, so we've got some folks that haven't tried it, but a lot of you are working into this area. Thanks for your participation on that. We'll move on to the next portion of the presentation here. So you sort of see the reasons why people want to do this. Let's talk about what are these integration technologies now. Again, the definition here, now the picture I put up is a picture from the scene at the end of Indiana Jones and the Lost Temple, and they're taking the Temple of the Ark of the Covenant and stuffing it in the government warehouse somewhere, and that's a sort of a bad analogy of this. But people think of that when they think of warehouses, so it's a sort of powerful motivator in there. Bill Edmond has been our thought leader in this area for many, many years, where he talks specifically about a subject-oriented, integrated, time-variant, non-volatile collection of summary and detailed historical data used to support the strategic decision-making processes of the organization. In other words, it's a place where you can go for one set of factual information. It's a great definition. It's very helpful from that perspective. When he says subject-oriented, he's thinking of things like products, services, places, things, these types of things. And integrated because you've already done the hard work. We don't want you all to take your knowledge workers, which are expensive resources, and have them spend their time doing this task. So we do it for you. And when we do it for you, we come up with some things that give you this place where you can go pull this stuff off the shelf. Time variant means we've integrated all the variables from a time perspective, so we can look at it by week, by month, by quarter, by year, by decade, if those are useful organizations. I was talking to some organization this morning, and they said they'd decided that they weren't going to keep any data in primary storage that was older than 4 years. For them, their business changes so fast, they said really at the end of 2 years, we don't need it, but we decided to be 4 just to be careful on that. Non-volatile means that when you put something out there as a fact, it is a fact. We will always have the fact with us that we delivered a data warehousing webinar today on this. So that is time invariant and non-volatile. It's historic now. It will have happened. Now, Ralph Kimball, his colleague as well, says a little bit easier definition. It's a copy of transaction data that's specifically structured for query and analysis, because when you put it in your transaction systems, it's designed for processing. It's not designed for query and analysis. So we need to re-architect the data to get it from our transaction systems into our warehousing systems. The key concept, again, is the subject, the fact that we need to restructure it in there, and that these are factual pieces of information that get into this. Now, the problem is that when we look at the causes of warehousing failures, nobody can seem to get the budgets right on them. The schedules are difficult, the functionality and capabilities are limited or not implemented correctly. The users don't like the results that they have. They are unacceptably long performance. They have poor availability. They are not able to expand and evolve as the business changes. They have poor quality of data, because if you put garbage in, you will of course get garbage out. That the entire set of technology is too complicated for the users that are there, and finally that the projects are not cost justified. Now let's take a look at, again, what we're trying to do conceptually. If I'm in an environment here where I'm looking at revenue from stores and electronics and different types of computing technologies, I can see that in one dimension of it I may put the products. What are the products that are producing revenue? And another, I may put what stores are producing revenue. And a third dimension in there, I may be looking at it across time. So you can see I can cube it conceptually. And when I do this, you get this emphasis on this n-dimensional cube, and allow the users to slice and dice different subsets of the data so that they can say, are laptop sales growing up? Are laptop sales growing in the Northeast? And how much revenue are laptops contributing to our total revenue? Just to give you 3 different examples of that. And again, these are different perspectives because we can't possibly anticipate all of the specific requests that the users will have on us. In other words, people with a warehouse and the right set of tools can drill anywhere into that collection, and that the entire collection can become accessible, and when they look at summaries, they can then drop down into different levels of detail. Here's an example from Oracle, and again, the DM Bach that we referenced earlier here that shows that we've got operational systems, and because their data wasn't designed to work together, it's unlikely to be integrated. It will be much more likely to be disparate, and that these operational systems then have their data reconfigured into this combination that you see here of metadata, summary data, and raw data. You'll notice some of it can be flat files that we can bring in from the side, and this is sort of the basic warehousing architecture where different users, some users are using it for analysis, some people are using it for reporting, some people are using it for mining, but the point is by having all this data in one place, they can use the same set of definitions, tools in order to do this. Now, again, our reasons for doing this is because data processing has started out as a collection of sort of applications that are specific to a specific function. Payroll, this application over here is for finance, this one over here is for marketing, and of course each of them develop their own set of applications and data that go with it. And when they have these set of applications and data that aren't designed from a central perspective, it is unlikely that these things will be able to work together. So as I try to connect the dots and find out how this data works with that data and how expensive are personnel on a financial basis and other things like that, it becomes very, very difficult and confusing. And our research shows that most organizations spend 40% of their time doing this type of non-value added work. And a well-designed warehousing integration technology can provide some support to this. In fact, the articulation that we like a lot is one that our friend Claudia Imhoff put together, again with Bill, on this, called the Corporate Information Factory. And if you think of how this works, you have your raw data approaching your factory from the left-hand side, and it's made into information products that are served for different uses out of a series of data warehouses. And I'll introduce another topic here, a data mart, which may be a subset of the data warehouse that is focused on a specific dimension or a different subject area in those areas. I've given you the rest of the information in here on the Corporate Information Mart. I'm not going to walk through it just so that you know that it is all there, but hopefully you can see that this is sort of an aspirational type of diagram where we'd very much like to have organizations move towards, because if we put some order on this, we are less dependent on individual heroic efforts, and those heroic efforts, as much as they are appreciated and recognized by organizations, also end up costing organizations a lot more in terms of time and money to do this. Now, I'm going to move very quickly from that to give you a contrast on this, which is to say that you can accomplish in many cases the same exact type of integration using alternative technologies to the warehouse. So please don't take away that I'm in any way or shape saying warehouses are not useful, but it's important to realize that they are not the only answer to these things. And that here's one example from a company that used to sell a product called MetaMatrix. And the idea was that this is a virtual construction. So everything that is in blue on this diagram is real, and the things that are orange are virtual. Let's look at an example, starting in this case from the bottom right and moving to the left. If you look over on the bottom right, you'll see contact and customers are combined from two disparate sources, but knowing that they can be combined to come up with that first orange table. And that can then be combined with some charts that allow us to give us some ideas of how customer views can be presented graphically to different people. So it's the second orange chart from the left that's on there. And then we can combine that with three more disparate fact tables. You can see, again, they're hard to read. It's customer management fundamentals and edits and references there that allow us to get to the eventual answer that we want, which is the orange table on the far left. But none of these tables that are in orange have to exist permanently. They can exist long enough for prototyping activities, for preliminary analyses, for proof of concepts, or for on-the-fly types of analyses. Again, this technology, virtualization, may be a useful alternative to your warehousing technology. Again, you all are the best people qualified to determine what works. And now that you know there's at least one alternative to warehouses, let's look at a second one. This is a wonderful example here. The actual physical example here is from Wikipedia. You can go look it up yourself. But a friend of mine took a warehouse that somebody had spent approximately $30 million building for a large government agency, and they were looking at tracking information. And they were taking the information, bringing it into the organization, harmonizing it, normalizing it, pulling it all together into one place, maintaining these data on disks that were expensive to run and use. And somebody finally had the insight and said, you know what? All of this data is accessible out on the web. And instead of making a second set of it internal, let's just link in the outside to where this data is. And the entire $30 million project that didn't work was reconstructed using linked data for 2 orders of magnitude less expensive. Your boss will appreciate it if you're able to go to your boss and say, I can build that warehouse or that integration set of information for 2 orders of magnitude less than you thought it was going to cost us. Now, this uses some relatively newer technologies called the semantic web, using uniform resource locators and another technology called RDF, Resource Definition Framework. All of these are very, very useful. Again, we're not going to go through them in detail here, but just to know that they accomplish, on the whole, very similar objectives in this case. So let's go a little further here again and talk about the architectural focus here. Again, Ralph Kimball has provided us a really nice area here that talks about the data warehousing chess pieces. And these chess pieces may be very similar to the things we were looking at in the linked area or the virtualization area, so the same concepts apply across all of these. And again, those are only 3 examples. There are some other ones as well. But what you're seeing here from left to right is that the operational source systems, they have data extracted from them. We may need to clean them. We may need to store them or restore them or reorganize them in different ways. Remember, the transactional data is going to be organized differently from how the analytical data is going to be organized, because we're going to link it in different ways. Remember, transaction systems are optimized for speed, whereas warehousing and integration technologies are optimized for access. Very, very different goals. And then again, there may be a set of processing that goes into it where we sort and sequence, reload it, and things like that. This is then moved into a data presentation area, the 3rd column, going from left to right, and this may end up in a series, as I said before, of data warehouses or data marts that may be connected with a bus type technology, either real or conceptual, so that we can integrate across them and then use a variety of our 4th column tools over there that give us access to queries, report writers, different analytics components, and most important for many organizations, different types of models that you use. Whether it's a forecasting model, a credit scoring model, or a data mining model, all kinds of things are extremely helpful there. Again, here's another vendor presenting a slightly different view of this. This is a medical view here of hospital information where we look across eligibility claims and electronic medical records, other types of things across the top, and we put them into one conceptual model that we can run dashboards, portals, and workflow managers off of it, allowing us then to move into sort of an analytics type space where we can run different things such as what happened or what's happening. That's a descriptive sort of thing, a predictive of what will happen or why does this happen, and a prescriptive model of, well, when it's happened or when it's happening, what should I do and why should I do the kinds of things that I do. This gives us then the ability to look organization-wide, to reduce the noise and volume, and to increase the utility of the data overall. And I've shown you the types of examples here. Shout out to my colleague Stephanie Bird for this particular articulation of it. She did a great job of looking across these things. Again, we did this from a piece of our work we did called a View from the Trenches at one point in time on this. Anyway, gives you the ability to score these things meaningfully in that organization. And here's an example that she took in where she was looking at how to treat hemophilia, where we move from sort of hindsight to insight to foresight in this area, so that then people can get grants, apply the right drugs, and look at specific outcomes so that we are improving the business value, in this case, of things that will happen. different types of analytics and reporting get called different things. It's kind of difficult. Again, the monitoring as in what's happening, is the heart still beating? Yes, we hope so, right? The reporting, which is, how many of these surgeries are successful, that's good. And then analysis, should we continue doing that surgery because it produces large numbers of successful outcomes? Again, very little standardization in this area, but what you really have to do is to look at it and say, what are we doing? Are we increasing the sophistication of the analytics that are going in there and the user interactivity, or are we increasing the range and number of the users? In many cases, we started out where only the physicians could look at this, and we extended it to nursing and physician assistants, and finally to customers, where it's helpful for us to get involved in our own electronics management of these things. Now, again, problems with this area tend to occur because you end up with a warehouse that looks like a healthcare provider that we looked at a couple of years back, where they had 1.8 million members, and in their data warehouse they had 1.4 million providers. That's almost one provider for every member. Sounds like this particular state in the Midwest was in particularly good shape until you did a little bit of further analysis of the warehouse and found out that 800,000 of those providers had no primary key. We couldn't access the data if we tried, and of course there's no point. Having no key was really a matter of not having the right number of digits that were involved in there. 29% of them didn't have a provider social security number, so we weren't able to get the information that we needed to from the system in order to do that. And to top it all off, this particular application, data warehousing application, cost $30 million, and it had one user. Now, here's clearly an IT project that has gone wild. There's absolutely no excuse for spending $30 million to solve a problem that the CEO of the organization said, I can take a room full of MBAs and accomplish this analysis faster. So again, we've got to have very, very tight integration on these things. Otherwise, you'll end up just like most of these, where you have poor quality data, many more values of gender code than just male or female. You have poorly structured data, which provides the correct answer to the wrong question, or you have an overly complex data warehouse design that somebody can't navigate. And the idea is, of course, that your data ends up someplace where you're simply not able to gain access to it anymore, just like this Indiana Jones thing we talked about before. Many business intelligence efforts are aimed at dashboards or scorecards. And what they're trying to do is to put something out there where people can look at something and see that everything's okay, except for maybe when something's not okay, and then we get a red light up on the dashboard or something like that. Many of the mobile applications are particularly designed to look at it from that perspective. There's an interesting scorecard here where you can see at the very core of it are the IT developers, then we have some analysts and information workers that come out. But really what we're trying to get to is the managers and the knowledge workers that are there, the frontline workers, and eventually customers, because if we can push the work all the way to the customers, and the customers can make the type of decision, it ends up being very, very useful. So these features become complex, and of course if we have bad data going into these things, it becomes horrible. Now, another term to watch out for is what we call forklifting the data, and you'll hear this term come about, where they simply take the data from the existing applications and move it very quickly into the warehouse with the idea that we need to be able to push a button and show that something works. My advice to you is, if you hear the word forklift involved in that, get involved in the project and find out more about it, because it's unlikely to have a successful outcome. And if you're able to go in and help them and say, look, just a little bit of data quality up front here, a little bit of metadata management might be extremely helpful, then you will be able to come in and help deliver some very significant value to that technology project. There's so much data, but there's so little insight, and this is even more problematic now that we've entered this area of what I call big data technologies. Again, many people shorten that phrase to big data, but it's really not useful to have a conversation about big data if we can't define it beyond the variables. We do a big data one of these webinars periodically, once a year or so, on it, and look at the latest trends there. But what this means is that there's so much data, but there's very little insight. As you know, the number of data points increases, the number of correlations increases, but that does not mean the number of causations increases. In fact, false positives go up. So the data translates into a greater need to make it, manage it, and make it more actionable in there. Also, market consolidation means we're ending up with fewer intelligence tools choices, so that the business users end up being forced to use things that perhaps they wouldn't otherwise use. And again, the choices between buying or building in many cases, and that becomes problematic as well. Business intelligence also then tends to increase the number of options that people have, so that these tools can be delivered at various levels of the organization. And this is the bring your own devices sort of concept, where people say, well, I want it on an Android platform, and half the people say, no, I want it on a tablet, right? And so they're back and forth on these. And the idea is, of course, how can you deliver it in a way that they will actually use it overall. Again, I saw a wonderful application this morning where somebody had taken the data and it was sort of sluggish on the web, but it performed very, very well on a tablet, which was the major place of their construction delivery methods in this case. The idea here also is that structured and unstructured, or as I prefer to call them, tabular and non-tabular data, allow people to come in, so that when I give somebody a business address, that we can go directly to that part of the web, and Google Maps can give us a lookup and a street view and things like this. Again, the idea is we're starting to combine things that have never been combined before. We used to call these things mashups. We've gotten away from that technology, I think, now to a little bit more useful technology in there. And finally, these applications allow us to get beyond the traditional pie charts and bar charts into something that is more interactive and more better indicative of what the actual trends are on these things. It turns out that there's a positive correlation between the number of insights and the level of interactivity that organizations have. So as people are working in these areas, if you can provide them faster and more data, they will develop better and better insights into it. But if they are not able to get access to the data quickly, then it becomes more and more problematic. So we're moving now to our second polling question. Again, we're interested from your perspective. Do you have a single data warehouse, coordinated marts, both, or are you uncoordinated at this point, or have none of the above? And we'll see how that correlates. We're going to take a quick 1-minute break here and let everybody give us some examples.
All right, we got about 20 seconds left to the close of the poll. All right, we'll get these results up for you guys. Let's see here. Okay, it looks like A, single enterprise data warehouse came in with 10%. B, coordinated data marts came in at 4%. C, both came in at 24%. D, uncoordinated efforts, 25%. And E, none, that was 30%. All 30%.
Okay. I was going to say, it's hard to add up to a large number there, but looks like we got it all right. All right, well, let's move on. Again, we're moving back towards the top of the hour. And let's talk about architecture and how these things focus in here. Again, the idea is please, 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 please do not start these things from scratch. These are just some of the very, very useful books that are out there. My colleagues David Marco, Len Silverstone, David Hay have written some. David Allen and I wrote one a couple years ago on XML in this area. And the idea is when you buy these books, these patterns come available to you. Now, what do we mean by patterns? Well, here's an architectural pattern. It's a metadata data model, okay, or a meta model. And this is the idea. Whoops, I'm sorry, I went too far. There we go. That if we're trying to connect things between different parts of a system, we can look at something like this and say, how is what we need to have different than this? Which is a completely different type of analysis and usually a lot more palatable to your subject matter experts than giving them a blank screen of paper and saying, tell me about your business. Again, the idea here is we can look and see that a screen element is linked to a data element, which might be linked to a stored data element at a particular location, and that is something that appeared on a printout. So where did that come from? That would answer that particular question. Again, this is one example of the models that are there. Here's another one. This is called the Common Warehouse Meta Model. And this meta model is something that they are improving. There's actually a new version out. We did not have a slide for it just yet. But what we talk about is to look at how your warehousing analytics are set up and what type of metadata you will need to have at a minimum to connect bits and pieces from one part of what you're doing to another part of what you're doing. Each of these gives you a great starting place for rebuilding or looking into what you need to do. Finally, my colleague David Marco and Mike Jennings' metadata model book. I don't have an example from Len here. I think Len did send me one of those. I'll have to remember to put that in. It gives you, again, an idea of a package. So you can start out and say, well, what does this look like? And both Len's book and David Marco's book come with a disk that you can then use to build out the entire metadata model from what you're starting on. So when you're starting with these warehouses, if somebody comes at you with a blank piece of paper, go and spend $35 to $50 at Amazon, pull this thing up onto a copy of Irwin in your organization and say, no, we're not starting from the beginning here. We're going to look at this example and see how we are like this example and different from this example. It's a much different conversation, a much better use of your time and expertise than it is to have somebody build this from scratch. The only person who wins when you build this from scratch are the consultants who start off and do this sort of work for you. And good consultants won't let you do that. If they've never heard of these resources before, you've got the wrong consultants on your team. Let's look specifically then at some guiding principles in that area, which is the idea of guiding this business analysis. If you're going to go after a high-value project, you need to have the best people on it. And guess what? The best people are busy. And so it's going to be hard to get the best people there. So you need to also investigate techniques for producing results quickly to make effective use of their time. Because it's very, very difficult to build and maintain these structures that you need to have. You can see what we were looking at before. This concept of the corporate information factory is a very complex animal. If you can get it to work, it also has the ability to produce very significant results. So we look at these things and say, what are the activities? We need to understand the BI and information needs of the organization. We're never going to be comprehensive. We can't boil the ocean. It's probably not a good idea to try to do even a big project the first time. Start small and learn to grow larger and larger. After you do 3 small ones, you'll be ready to tackle a big one. You need to tackle these by defining and, more importantly, maintaining the data warehousing, analytics, BI architecture that you're going to put in place, which means understanding how your transactional environment works and how you can use architectural principles to transform that data into something that can be then used for analysis. You need to process the data to get it ready for this type of analysis, whether it's BI or analytics. You need to implement these things called data warehousing and data marts. Now, there's specialized hardware and software that you can buy, but we recommend that you start out actually quite small and build it in something off the shelf. SQL Server, Oracle, if you're an Oracle shop. And by the way, Oracle does have its own share of data warehousing technologies that are very, very good. But you don't need to start off by buying the technology. Start off by trying to use the functionality and assess how that functionality is used by the business to add value to your organization. Because, of course, once you implement these tools and the various dashboards, what we call the user interfaces, you also can't leave them running. You need to monitor and tune them just the same way as you need to monitor and tune every aspect of your technology environment, which means you also need to look at the activities and performance that are going on around it. And in many cases, we find that you need to also go in and re-engineer your business practices and activities around them. because if you don't do that, you will end up with a very unbalanced system. A high-performance technology system in a low-performance process environment, or a low-performing technology system in a high-performance environment are mismatches, sources of discomfort, and areas where the business value is not derived. Let's look at the deliverables that will come from something like this. You again need to have a data warehousing BI analytics architecture that you can use to extend the existing data architecture that you have covering your transaction environment. If you don't have an architecture for your transaction environment, I should say this carefully, you all have an architecture for your transaction environment. You also have one for your BI and analytics. The question is, do you know what it is? Because if you don't know what it is, you can't make use of it. So can you make use of the analytics environment to complement your existing transactional structure? If you can't, there's no point in going out and building a bunch of data warehouses, cubes, and marts, because you will be providing the correct answer to the wrong problem. Same thing with dashboards and scorecards. Management wants them, but if you provide rubbish, then you're going to have not a lot of happy users on your hands. You may want to get into, in fact, creating specific applications around analytics, looking at various different types of extracting information so that your data mining operations can become more efficient and effective. Looking at your BI tools and your user environments and deciding whether you should have one or several or a bunch. Again, our average seems to be, when we go into big organizations, they have about 6 different types of these, and that's probably too many. We're seeing really that most organizations can get by with 2 or 3. We've actually found as many as 20 in some organizations. There also are, of course, data quality feedback loops. When we're starting to feed this data out, again, the executives and users of these systems are going to be the ones who are going to know and understand the quality of the data that's there, and that's the last thing you want to do is leave them with poor quality data in there. There's different groups that you have that you do this. Again, the suppliers of the resources, the participants that help you build them, and the consumers of these things. It's absolutely critical that you work in a very, very useful, productive fashion so that people can gain access to these different sources of expertise and respect the various contributions that are being made. The consumers are not going to understand the technology, the executives aren't going to understand the consumers or the technology, and the consumers and the technologists are not going to understand the motivations of the business executives who are formatting these things. Again, from a technology perspective, it can be daunting. You've already talked a little bit about extract, transform, and load. There are some very specific change management tools that you need to have. Again, data modeling tools, data profiling. If you don't know, data profiling is something we cover in our data quality seminar on this, but profiling is the idea of looking very detailed information at the data out there and coming up with overall assessments of how it can be used. How many of these things that are supposed to be phone numbers actually are phone numbers on this. This gives you the ability then to select the right type of cleaning and integration tools that you may or may not want to incorporate a reference or master data type application technology into this environment. This will give you then the ability to look at the processes that you have surrounding these things and look at process modeling tools. And one of my favorite discoveries in the last couple of years is a tool that helps me to reverse engineer organizational processes. Very, very useful technology. Comes from Finland, a really, really terrific group of folks out there that are working at this, and metadata repositories as we look at them, which then can lead you to some cool things such as business process and rule engines. Again, we're just touching on these things here, but these are all parts of the thing that you can take a look at overall. So guiding principles in this area, let's take a look at obtaining executive support and commitment, securing the access to the subject matter experts that you need. One of the hardest parts of this is I've got a great idea, but I can't gain access to the business people to tell me how to actually use it in practice. You've got to be business driven. You've got to let the business drive the prioritization. You've got to make sure that you do data quality up front and not let people forklift the data in there. That it's important to achieve incremental value. A 90-day deliverable in many of these things is a very, very good metric to use. You've got to have transparency and self-service ability in there at some point. It doesn't have to be all the time, but you've got to put it out there so that people can start to use it. You've got to understand that what works for large organizations may not work for your organization, and even if you are a large organization also. Again, one size does not fit all, so you've got to be familiar with the tools and the products for each of the segments that you're working within. Again, thinking and acting globally but building locally, very, very critical on this. And make sure that what you're doing works well with everything else, because you'll find pretty quickly people will be using your data warehouse systems to then feed other systems as you put high quality, reusable data in there. So starting with the end in mind, and then look at summarization and optimization last, not first. Don't try and get it absolutely perfect. So again, one quick question here for you we have. I'm sorry, that's not right. We've got one more question on this. Do some architecture, model the details, provide the architecture early, focus on the usage, organize your work around the requirements, and get active stakeholder participation in there. Here's our third question we're interested in. Do you have a separate data warehouse group, or are they integrated with everything else that you have in the organization? Again, another quick minute on that, and then we'll get to some closing remarks.
All right, so there's about 25 seconds left. You guys are still getting in answers, so get a little bit more time. All right, let's open this up so you guys can see. So it looks like 38% of you responded with A, yes, and 29% responded with B, no.
Okay, interesting. So we're still seeing a lot of work in those areas. We're going to give you some analysis on those things and give you a little bit of feedback on that in a future webinar on that. But anybody has any specific questions about the motivation for those questions, be happy to talk to you about it in more detail during the Q&A section. So again, what we've talked about is what is this idea of warehousing and integration. And we've done this in the context of 3 complete seminars on this. The first one was, again, metadata. If you're working with integration problems, you must deal with metadata. Secondly, if you're looking at integrations, you need to consider cloud. If you're in the government, you're actually mandated to consider cloud first, but if you're in industry, you should at least take a look at it because it offers some very powerful advantages in there. And thirdly, warehousing, you've got to have business value that's got to precede the actual technical design. If you don't have that business case for it, don't bother spending your money on any vendor products because there are other non-traditional alternatives that are available there for you. We are at the top of the hour here. Again, I've always included some references here for you to go through and take a look at in this area, and we now move to our Q&A section. Megan, I'll see if we've got anybody that's got any questions.
Alrighty, thanks, Peter. That was a great presentation. Now it's time for you all to ask your questions. So just click on the Q&A feature at the top of your screen, and you should be able to submit your questions through that Q&A window. So we'll give it about a minute here so people can get their questions in, and then we'll get started. We actually had a request come in, and someone asked if you could go back to the previous slide before pulling question 3, Peter. Maybe just to do a quick review on that. They didn't have any specific questions to go with that just yet. But
I did go fast on that one, so sure, I can certainly talk a little bit more about that. Again, the idea here is when you're looking at building these warehouses, particularly if it's the first time through, it's unlikely you're going to get it perfect. So most people turn around and they bring in a data warehousing consultant who starts talking about data warehousing. And the real key for this initial architecture and visioning is that you're trying to figure out a way of providing business value. Because we can provide databases and we can build data warehouses. The question is, can we do it usefully? And that question is still certainly, let's put it this way, for people that can build data warehouses that can provide valuable ones. So I worked with a company recently that had 2,800 data warehouses, and they looked at how much time and effort they were spending moving data between the various data warehouses, and they decided it was an absolutely abysmal process, that there was very little business value coming from these 2,800 data warehouses. So now they're looking at re-architecting it down to a series of less than a dozen, and that these data warehouses, they feel now, will be able to provide a much higher business value than they were able to get before. So that's clear, excuse me, on that particular question.
All right, and the next question is, what is meant by government is mandated to look into using the cloud first?
So the government put out something 2 years ago, Anish Chopra, who was the CIO at the time, that is called the Cloud First Mandate. And if you Google that phrase, Cloud First Mandate, you will see a copy of his memo that says that the federal government's IT spending has been largely unconstrained in recent years, and that one of the things the federal government wants people to do is to get better at cloud. So the Cloud First Mandate says that you should consider the cloud explicitly as a first option. So it's sort of forcing people to do it. It's kind of like another law that we helped to pass early on called the Klinger-Cohen Act, which means it's against the law for anybody in the federal government to buy information technology goods or services that don't complement their existing architecture. I'm unaware of anybody going to jail for violating the Klinger-Cohen Act, and I don't think I know of anybody that will be in trouble with Anish Chopra's Cloud First initiative, but it is saying it is a technology that is promising and we should look into it. So I hope that gives you information you can go help to find, because it may help you to come up with a good solution for problems that the taxpayers are trying to help us to solve here in the government space.
Okay, great. The next question is, do you have any sources for industry best practices for gathering requirements? Any sources for templates?
Wow. Yes, book, I didn't put it on that particular list because it's a requirements book, but again, David Hay, H-A-Y, a colleague of ours from Texas, has written a book specifically on requirements, and probably is out at Google that we could get, but he did a terrific job on that book. Let me think. There's another book, Gerald Weinbaum, I think, and I think it's called Exploring User Requirements. That's another one, but that would start with David Hayes because he's definitely got some things in that area.
Okay, and the next question is, what is real-time data warehousing?
So data warehousing, as you've seen from these complicated architectures, can have a refresh cycle time. In other words, when you look at your bank balance, if it's coming from a data warehouse technology that is not real time and you withdraw $100 from it, that might not get reflected until a batch job at night updates that information. Real-time data warehousing is used in situations where you have perishable quantities of things. For example, I was recently trying to get an Amtrak ticket to go from Washington to New York for part of the trip that I'm on this, and the real-time Amtrak system tells me there are no seats available on the on the train that I want to take. So the real-time warehousing may be concerned with that type of performance. It's certainly not applicable for everything, but in certain instances it may be very useful to you. So again, you're the best expert there. You use your judgment and figure out whether a real-time architecture is something that's going to be useful for you or not for that particular application.
Okay, and the next question is, what is a cube in data warehousing concepts?
So I must not have done a good job on that one. Let me back up a couple slides. And thank you for asking the question, because it's always good to see if I'm delivering what I'm trying to do. So the cube is one of the core concepts in warehousing. And the idea here is the example that I gave you in this set analysis. Sorry, I'll just put the slide up there on the screen so you guys can see it. Is that we start off with a list of customers and we're using the cube to go in and slice and dice the cube from 30,000 to 6,000 to 8,000 to 40 suppliers, and that turns out to be the answer for this particular analysis. Now we call it a cube, and it's really, just like everything else in IT, a very poorly named cube, because it's really only a cube if your analysis happens to have exactly 3 dimensions. Very few data warehousing analyses are limited to just 3 dimensions. So the idea of this cube here, you can see this cube has the dimensions of products, time, and geography, would only really apply as a cube under the circumstances where you had 3 dimensions. The whole goal of a warehousing analysis is that users can go in and drill anywhere, and that's why we call it an n-dimensional cube, because there can be any number of dimensions. I've seen warehousing analyses with 12 or 15 different dimensions on it, and the queries get very complicated if you're programming it in SQL, but if you're in a nice warehouse with a good front end on the end of it, then users can drill anywhere and dive down into that. So great question. Thank you for asking that. I hope it's helpful and clear at that point.
Okay, and the next question is, with a very high rate of failures in data warehouse projects, would you consider an ERP similar to a warehouse? Can most of these concepts be used for ERP implementation?
Yeah, that's a great question. Okay, so it's a 2-part question. First part of the question, was the failure rate the same? And the answer is yes. First of all, there's a direct inverse proportion between the size of the project and the success of the project. And the larger the project is, the less it is likely to be successful. The biggest boondoggle failure so far that we've managed to come up with is the 11 billion pound failure of the National Health System in the UK, where they spent $11 billion of taxpayer money to build a very, very large environment there. Now, that's large projects, whether they are warehouses or ERPs, are more likely to experience challenges. They're more likely to fail than others. Turns out the failure rates for warehousing and ERPs are exactly the same. In fact, the number 7 tends to apply to both of them very well, and it's a wonderful number. If you think about the common wisdom is that the average chief information officer is only on their job for 18 months to 2 years. And if you then say buying an ERP or building a warehouse will generally make things worse for the next 6 years, and on the 7th year things will get better, that means that the CIO is investing in their successors' 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 success. And nobody in their right mind would do that. So there must be not good knowledge of these failures. Now, the question that you asked in addition to that was, can you use an ERP in replacement for a warehouse? And the answer is generally no. Many ERPs claim to come with integrated warehousing environments, and some small subset of them are actually okay to use. But the vast majority of the data that is processed by an enterprise resource planning project like SAP, PeopleSoft, or Oracle applications is transaction-oriented, and those transactions are not focused on analysis, which means it's going to be very difficult for you to perform the kind of analysis that we're depicting in these slides here for users to drill anywhere. You can, in an ERP, go in and pull out a particular question and see that me, Peter, wrote a check to this organization for this amount of money on this date. But getting my spending patterns from the transactional data will be very difficult unless you put it, re-architect it, into a warehouse. Great question. I hope that helps with the difference between the two.
Okay, great. And next question is, what is hierarchy in data warehouse terms?
Hierarchy is a way of organizing the data. I don't actually have a slide that shows that. It's a great suggestion. I'll put that in next time. Let me see if I can walk you through one. If we think about warehousing as looking at aspects of the business that we need to know more about, one of the typical places that businesses start off trying to find out about what they're doing is with the term customer. And when you look at a customer, we say, okay, great, that is a thing I'd like to have. I'd like, therefore, a customer data warehouse. Now, it gets really quite funny here at this point because we have almost every organization that follows in the same pattern, which unguided, hopefully you'll see, is kind of a typical sort of thing. Okay, customer. Now, let's tell our customers that we're having a sale. Okay, well, if you tell your customers who just bought something yesterday, the thing they bought yesterday is now on sale, you've now increased the cost of servicing those customers because a lot of them will come back and ask you for the sale price, which means you have to adjust their transaction, which means the data that went in the data warehouse the first time to show you what the sale was now has to be changed to show that it in fact wasn't the sale price, it was 20% off because your customers were told by the marketing people that the thing they bought yesterday costs less today than it does yesterday. Now, your question specifically was about the hierarchy, and hopefully you can see here the utility of dividing your customers up into at least two categories, current customers and potential customers. And if we have a current customer, we don't want to tell a current customer that the thing they bought yesterday was on sale, but we are perfectly good to tell our prospective or our potential customers that this thing will be on sale. Now, that's an example of a hierarchy that we would put in there. We would put down in the customer data warehouse the different types of customers categorized according to that hierarchy. Now, the hierarchy gets a little bit more complicated as you start introducing other concepts into it. For example, how would you put out the concept of X customer? Is that a current customer who doesn't like us anymore? Or is it a potential customer who could be turned into a current customer? So this need for formally managing the vocabulary of the organization is why we use these hierarchies, or another word for them are taxonomies. And eventually you'll hear the word ontologies come into this, which is how we organize knowledge about our business in general. Again, great question. The warehouse should represent the formal hierarchy of the organizational vocabulary that we're going to use so that everybody can literally sing off the same sheet of music.
Okay, and the next question is, what is the main difference between Inman, and Kimball philosophies of data warehousing?
So if you ever go back and hear either of the two of them, there's a lot more controversy in the press than there is actually between the two gentlemen. They're both really wonderful individuals. Their basic philosophy here is that Bill has gone on and put in place a fairly narrow set of constraints here where he talks about some very specific characteristics. Again, subject orientation, integration, time varying, non-volatile collection of summary and detailed data here, whereas Kimball has a looser component of it. And basically, Inman is a proponent of organize it to support the strategy, and Kimball is what you'll hear associated with a STAR schema set of technologies. What this is again different ways of organizing it into the patterns that I was talking about later in the presentation, a la the David Hay, David Marco, and Mike Jennings, and Len Silverson presentations that were that I spoke about in there. And Kimball's way of approaching that is no better or no worse than Bill's, and they will both agree to this, but different focuses for your analysis may lead one or the other to be a better model for you. If you look on the web, you'll see there's, quote, controversy. There really isn't. They're both wonderful people, and they have so much more in agreement than in disagreement that they laugh at the differences between the two. But again, think of Kimball as STAR schema and Inman as being a little bit more restrictive on the overall focus of the data warehousing.
All right, it looks like that is the end of the questions for today. Thank you everyone for participating in today's event. We hope you have enjoyed it. Thanks again to Dataversity and Shannon for hosting us. Once again, you will receive today's materials within the next 2 business days. Our next webinar will be Show Me the Money, Monetizing Data Management. Hopefully you'll be able to join us for that as well. As always, feel free to contact us if you have any questions. Thanks everyone and have a great day.
Thanks, Peter. Thanks, Megan. And thanks again, everyone, for attending. That was another great session. And like Megan said, we'll get the email out to you with the links to the slides, the recording, and some of the nice books that Peter mentioned as well, so you have those handy and available to you. Peter, another great presentation. Thanks again, and thanks to Data Blueprint for another great series.
Thanks, Shannon. Thanks, Megan. Bye-bye.
Thanks, guys. Bye.